Hello everyone. In this video, we'll be doing question number 4 of exercise 1.5 from your NCERT books for class 9. The question states, represent root 9.3 on number line. So let us see how do we do that. We take up any line. On that we take a point A and we take a point C such that AC, we need to draw 9.3, so we'll take up a point C such that AC is equal to 10.3, one more than 9.3. 9.3 plus 1, so it is 10.3. Then I take up point B such that BC is 1 centimeters. Now BC is how much? BC is 1 centimeter. AC was 10.3, so and BC is 1 centimeter, so AB comes out to be 9.3 centimeters. Now I need to find out the midpoint of AC. So for that, what do? I take A as center and I take the radius more than half of AC and I make an arc on one side of AC with the same radius. Without changing the radius, I make another arc on the opposite side of AC. I do not change the radius, and with C as center, I make two arcs intersecting the previous arcs at point P and point Q. Then I join PQ with the ruler. Wherever this PQ is intersecting the line segment AC, I mark that as point M. So this is the midpoint. I will mark this as point M. Now with M as center, radius equal to MA or MC, if I will make a semicircle, that semicircle will pass through A and C or not? Now, what is the next step? You know that AB was 9.3. So at B, we will make a perpendicular to intersect the semicircle. I know the construction of the 90-degree angle. So for that, what do? So I make an arc wherever this arc intersects the line segment AC. With that point as center, I make another arc taking the same radius. Let this arc cut the previous arc at point O. Now with O as center and the same radius, I make another arc to cut the previous arc at point R. Now OBR is how much? It is a 60-degree angle, and NBO was how much? It was 60 degrees. So if I bisect angle OBR, I will get an angle of 90 degrees. The point of intersection of the arcs, it comes out to be as D. I join BD, then BD will be the perpendicular to the line segment AC. Now, wherever this perpendicular is intersecting the semicircle, I mark that point as point E. This BE is the important radius. I take the same radius as equal to BE and I make an arc to intersect AB produced at point, let's say, X. So if I take B as the 0 of the number line, then X will be how much? X will be equal to root 9.3. Let us see the justification for this. Supposing I want to draw root X. So for that, what is the procedure? I have drawn this as equal to, let's say, X centimeters, and this is 1 centimeter. BD is the perpendicular. In triangle MBD, DB is perpendicular to MB. Therefore, by the Pythagoras theorem, what will we get? We will get MB square plus BD square is equal to MD square. This was X plus 1. See, AB is equal to X, BC is equal to 1. So AC comes out to be X plus 1. So if this complete is X plus 1, so MC is equal to half of AC. So that comes out to be X plus 1 upon 2. This is the radius of the semicircle. So that means MC will be the radius of the semicircle, which will be equal to MD, which will be equal to X plus 1 upon 2. Now this complete is X plus 1 upon 2. From that, I need to remove this 1. So that means this comes out to be X plus 1 upon 2 minus 1. That will give me the value of MB. So I put the values here. MB is equal to X plus 1 upon 2 minus 1. MD is equal to X plus 1 upon 2. Let us simplify them. X plus 1 whole square minus X plus 1 upon 2 minus 1 whole square. I simplify this. If I take 2 as a LCM, this comes out to be X plus 1 minus 2. That means X minus 1 upon 2 whole square. To get how much? X plus 1 whole square upon 4 minus X minus 1 whole square upon 4. I take 1 upon 4 common and I will be left with X plus 1 whole square minus X minus 1 whole square, which gives me X plus A plus B into A minus B. x plus 1 plus x minus 1 into x plus 1 minus x minus 1, which simplifies to give me x and x, that is 2x, into 1 plus 1, which is equal to 2. So I get 1 upon 4 into 2x into 2, which gives me equal to x. Now BD square is coming out to be equal to x. That means BD comes out to be root x. So BD comes out to be root x. I need to draw root x. Then I make the length equal to BD. So then this point where this arc is intersecting will give me the value of root x. So taking b as a 0 of the number line, x represent root x on number line. So this statement is very important if you are represented on the number line. Let us take up now x equal to 9.3. Exactly same way. Now I have this as 9.3 and this as 1. So this comes out to be this BC, the radius of the semicircle comes out to be 9.3 plus 1 upon 2. That means MD, the radius of the semicircle, is 9.3 plus 1. MB is what? The radius minus 1. That means 9.3 plus 1 upon 2 minus 1. Let us put them in this using the Pythagoras theorem. I get MB square plus BD square is equal to MD square. MB I just now found out to be equal to 9.3 plus 1 upon 2 minus 1. And MD I found out to be 9.3 plus 1 upon 2. Using that, if I just try to simplify it, I will get BD simplifies the same way equal to how much? It will come out to be 9.3. So if BD square is 9.3, automatically BD comes out to be under root of 9.3 centimeters. With BD as radius, I have made this arc to intersect this line at point X. So BX is also equal to BD is equal to root 9.3 centimeters. Taking B as a 0 of the number line, X represent root 9.3 on the number line. So I hope it is justified. How have we drawn? I just repeat. I took first of all a line segment AC equal to 9.3 plus 1. Then I found out point B, said that BC is equal to 1 centimeter. Automatically AB comes out to be, that means 9.3. I find out the midpoint of AC, that is M. With M as center and radius equal to MA or MC, I will make a semicircle. Then at B point, I made a perpendicular. Wherever this perpendicular intersects a semicircle, that point I mark it as D. Then BD will be equal to under root of 9.3. So with BD as radius, if I'll cut an arc intersecting this line AB at point X, then X will represent root 9.3, taking B as the 0. So I hope it is clear to you. Thank you so much.